1, start.
Good morning, everyone. Where safety and access collide, our team, Neural Nexus, set out to answer the tough question. Going to the next slide, we, Team Neural Nexus, focus on the top 8% of Virginia's most dangerous and undeserved roads, areas where crash rates are high and public transits are almost non existent. Our approach is quite simple but powerful. Map the danger, spot the gaps, and align the fundings. What we built is more than a solution for today. Moving forward to the next slide.
Once we had a question in place where Virginia's roads are both dangerous and underserved, we didn't want to just look at spreadsheets and tables. We wanted to actually see the problem come to life. So the first thing we built was a heat map, and it immediately highlighted where the risk was glowing brightest. It gave us a powerful visualization starting point to zoom in on the right areas. Next, we dug into the fatality trend shifts over time. Instead of just counting crashes, we asked, where are these getting worse? That year over year perspective really helped us see which locations are heading in the wrong direction. And finally, we built a predictive layer. By combining public transport access, safety scores, and even funding patterns, we started to map out where the future problems might show up before they do. Altogether, these three steps mapping, trending, and forecasting gave us a solid foundation. They helped us move from just identifying problems to actually building a smarter strategy to fix them.
How did we do that? So we analyzed thousands of rows of data from vehicle crash records from DMV, and we cleaned and standardized the data, converting speeds, handling missing values, and categorizing harmful events. Next, we created a custom crash severity score, combining indicators like vehicle damage, towing, speed differential, and type of collision. We then used clustering and speed analysis to segment crash types and understand the role of speeding in severity. A correlation heat map showed that vehicle disablement, towing, and speed were top predictors of severity. To move from analysis to action, we introduced a mismatch index, identifying crashes where vehicle behavior and road design don't align. For example, running straight into the fixed objects at high speed or during turns. We then filtered and grouped crash IDs to identify repeat high severity locations and generated a custom policy recommendations like speed calming boards, barrier upgrades, or intersection redesign. The final outcome is an interactive map color coded by severity with pop-ups showing the vehicle type and the exact insight to help pinpoint exactly where and what kind of infrastructure investment is needed. In short, we translated rock crash data into actionable urban planning intelligence, helping agencies prioritize safety investments based on real patterns, not assumptions. And this is how our tool looks like. So if you zoom into the particular location, it gives us the actionable insight for that particular instance. And then we analyzed the year over year change in fatal crash involvement for different vehicle types. Passenger cars, light trucks stay fairly consistent, but motorcycles show major spikes, especially in 2008 with an increase of 80% increase. The large trucks fluctuate and the most early on. These trends help us identify which vehicle types may need more attention in future safety planning.
So, taking that question a step further, this slide gives us some real clues as to why certain areas are still falling behind. On the left, we're looking at how the government has been spending money across different transportation modes over the years. Highways, super consistent. The forecast and actual spendings are almost identical. But when we look at railroads, the story changes. The funding's not only low, it's all over the place. That volatility tells us the support for alternatives like rail just hasn't been stable, which makes long-term improvement hard to plan. Now, if you glance at the chart on the right, this really brings it home. Highways take up over 70% of total transportation spending. That's huge. And when transit, water, and rail are barely getting a slice of pie, it's not surprising that many high risk areas do not reliable public transit options. To actually make a difference, we need to think just beyond roads and start looking at how more balanced, targeted spending could reduce crashes and improve access in undeserved communities. Next slide.
So moving on to the recommendations from our analysis, we will be providing value to the community as well as the Commonwealth. To ensure that there are proper safety measures, we ensure that it reduces crash frequency and severity, protecting vulnerable road users like children, cyclists, and pedestrians. Secondly, It helps in faster emergency response, which enables quicker deployment of emergency services by pinpointing high risk zones. How we provide value to the community would be selling this as an API, like Google, integrating it with Google Maps API by offering real-time crash risk data to improve route safety for commercial and public transport, potentially generating revenue. And secondly, it's a cost-efficient way which supports data-driven investments in infrastructure and safety upgrades, optimizing public spending. We would like to thank you for this opportunity, and these are the references that we use. Thank you.